Well, hello guys, Mr. G here with another video of the control test for the grade 12 in 2023. This time we're going to be looking at question 6, which is about physical properties, and if we have time, we'll go to question 7 just to finish these videos on this question paper. This question 6 said, the relationship between boiling point and the number of carbon atoms in straight chain molecules of aldehyde, alkanes, and primary alcohol is investigating curve A, B, and C are obtained. And you have this graph in which A, B, and C represent these compounds here: aldehyde, alkanes, or alcohols, and all the alcohols are primary alcohols. Okay, so now, before we moving on, we have in here the boiling point. We have aldehyde, we have alkanes, and we have alcohols. So now, what are the different type of intermolecular forces that each of these different homologous series have? Let's start here with the alcohols. So the alcohols will have hydrogen bond. Apart from London forces. The alkane will have London forces only London forces. And the aldehyde have dipole apart from London forces. Okay, so if we go here, we know that out of these three compounds, and I'm going to order them from stronger to weakest, the hydrogen bond is the strongest one, so I'm going to give him a 1. Dipole is the second strongest one, and London forces is the weakest one. Alright, so that is important to know before we carry on. You're supposed to know this one, guys. Now, when we go to the question here, the boiling points are increasing for each of the compound. And remember, the relationship said that the stronger the intermolecular forces, the higher the boiling and melting point for the same number of carbon. So if you see here, for instance, for 8 carbon, each of them, A will have the highest boiling point. So A, guys, is going to be an alcohol. A is the alcohol. B, therefore, is the aldehyde. And C is the alkane. So this analysis is important to do it even before you carry on with the question. Now we know each letter which compound represent. Okay, now we can go to answer the question. Say, define the term boiling point. And now, what is boiling point? Boiling point is the temperature at which vapor pressure equal atmospheric pressure. This is the definition for boiling point. Quite simple, guys, and is important to know because it's almost always in one of the exams. Write down the structural formula of the functional group of the aldehyde. And be careful because people attempt to be very fast here. Structural formula of the functional group, not of the aldehyde. Functional group of the aldehyde, and we're going to do it real fast here on top. It's not a need to go away. We have a carbon which is double bond to one oxygen, single bond at hydrogen, but we cannot stop there, guys, because carbon must have 4 bonds, so we need the bond there. So this one here is the structural formula of the functional group of any aldehyde. So any aldehyde will have this functional group in the structural formula. Question 6.3. The graph shows that the boiling point increases as the number of carbon atom increases. Fully explain this trend. Now, they are not talking about the increase of the boiling point from a C to A. They say for the same compound, you can see for C, the boiling point is increasing as you increase the number of atoms. You can see it here in the line going up. It's increasing, and each of them is doing the same trend. They are not talking about A, B to C to B to A. So they're talking about the number of carbon, and we're going to explain that one in the next page. Okay, now here the first thing you have to say is that increasing the number of carbon atoms will increase the molecular mass. You can also say surface area or length. I personally prefer to say surface area. The number of carbon atom increases the surface area. That is the very first point you have to speak here. We're increasing the number of atoms. The second important thing is to say that because of the surface area increases, more site for London forces to form, and therefore the strength of the intermolecular forces increases. These two are interrelated here. You have more sites of London forces, and therefore the strength of the intermolecular force will be increases there. Now you need to know that this is for any of the three compounds. Each of them will have London forces apart from a special type of forces in the alcohol and the aldehyde. So the London forces is the one that is affected when you change the length of the surface area of the compound. The London forces is the one that is going to be affected because of the surface area. Please remember that one. And guys, that's it. The last point of here is that more energy is required or needed to break the intermolecular forces, guys. That is the last point. And I want to emphasize in something. You cannot write to break bonds because it's not the same. If you write the word bond, you will lose the marks, and sometimes even more than 1 mark. So this is question 6.3 is quite simple. It's the relation between strengths of the intermolecular forces, which in this case will be the London forces, and the surface area. Let's go to the next question. And we are here. Identify the curve A, B, or C that represent the following compound with hydrogen bond. We said it's the alcohol, and therefore that one will be A. That will be A. Be careful with the type of intermolecular forces for each of them. The aldehyde, and that one will be a B. Now explain your answer. Why this the aldehyde, guys? Okay, well, aldehyde have stronger intermolecular forces than C, but weaker intermolecular forces than A. Therefore, the boiling point of B will be of aldehyde will be higher than the alkane, but lower than the alcohol. So here, what do they want you to say? Aldehyde have dipole that we already mentioned before. Alkane, London forces. And alcohol, hydrogen bond. This one is for question 6.4.2. Now, dipole is stronger than London forces. Stronger than London forces, but is weaker than hydrogen bond. Okay? In this case would be in the middle. Is stronger than London forces, but weaker than a hydrogen bond. So finally we have to say that B needs less energy than A, but more energy than C to break the intermolecular forces. So this is question 6.4. This is question 6.4. The combination of this here and this here is also 6.4. The question 6.4. Okay, so that one is quiz 6.4. It's quite simple. You have to compare with it already, speak about it on here, but I just wanted to now write it down. I think it's not the need to go to a new page. You have to organize that one in a nice paragraph. Use the information in the graph and write down the IUPAC name of the compound with a boiling point of 473. 473, we are here. We are at this point, the 473. So it's an alcohol that has 4 carbons. You see the number of carbon down there. So it's an alcohol that has 4 carbon, guys. Alcohol, and remember they also telling you it's a primary alcohol. So it's a primary alcohol with 4 carbon, and the name is quite simple. It will be butan 1-ol. That is the answer, not analysis needed. It's quite simple. Okay, the analysis in the graph to know which one they're asking you for. Butan 1-ol. Write the IUPAC name of the compound containing 5 carbons atoms which has the highest vapor pressures. Now, the highest vapor pressure will have the lowest boiling point. Highest vapor pressure, lowest boiling point. Okay? So in this case, we go to 5 carbon, but will be the C. So it will be the alkane that has 5 carbon, which is pentane. It will be pentane. And that one will be the end of this question. It is enough time to do question 7. I hope this question was quite clear. It's not that bad. It's a very simple question, guys. So let's go to question 7. So question 7 is about reaction. I personally don't like this type of questions too much, but they are not too bad. So let's have a look. The following diagram below shows how alcohol can react to form other compounds. Okay, now we're starting with alcohol, which is a saturated compound. It means only single bonds. That is what I meant there. Here we have a haloalkane, which is also saturated, therefore this is substitution. There is a video done on type of reaction, on different type of reaction, guys. Please go and watch it, and it may help. Now here you have reaction C and reaction B. Reaction C is going from a secondary alcohol to compound Z, and compound X is going through reaction B to compound Z as well. And then compound Z, you have reaction D where you add hydrogen and you get alkane. And very simple analysis here. If you add hydrogen to a compound and you get an alkane, it means that compound Z was an alkene. And that reaction D is going to be addition. Okay? It's going to be addition in which you add hydrogen, and therefore if you want, or if you will, it's hydrogenation. Okay? Now, if this is addition and this is an alkene, reactions C and B are elimination. So we go to elimination, but we don't know yet the type of elimination or anything is not needed so far. We just identify the main type of reaction, and I just identify the main type of reactions there. Now they said question 7.1, write down the type of reaction represented by A. A is substitution. You see, this is helping because we already know the idea there. So A is substitution and D is addition. We have substitution and addition. Question 7.2, write the IUPAC name of compound C. Now compound C, as you can see there, here, is going to be a haloalkane. You have a C, let's draw the structural formula here. C with 3 hydrogen, another C with hydrogen and chlorine, and then another C with 3 hydrogens. So as you can see here, this is the compound, the structural formula of the same compound, if you think you are going to get confused, guys. So now let's follow quickly the steps. It's quite simple. First of all, it's a haloalkane, and the 4 will finish in ane. Second of all, the longest continuous carbon chain is straightforward. They have 3 carbon, and it's going to be prop. It's going to be prop. Let's move all this one a little bit to the side here, preventing something later on. Okay, and then what else? You count the carbon starting from the end nearest to the functional group, or substituting when you have a haloalkane, but in this case the haloalkane is right in the middle. You can see there is in carbon 2. So the substituent is the chlorine, which is in the second carbon, and therefore it will be 2 chloro, and the rest is combining the name. So the name will be 2 chloropropane. That is the name. They're very simple, guys. So let's write it down here actually for the question is 2, now with the marker, is 2 chloropropane. Quite simple. Balance equation for reaction B, and reaction B that we are going to do. For this one we need a new page. Okay, so let's start with the reactants. The reactants is going to be the 2-chloropropane, which is right, plus the potassium hydroxide. So this one is the reactants here. Now what is going to happen? This one is going to be elimination, guys. What is going to be eliminated? The chlorine obviously must go away from here to be eliminated. Now with the chlorine, one hydrogen must also go away. In this case, it's quite simple, is one of the hydrogen on the side, either one. I'm gonna take this one here away. So what will you have on the other side there? You will have still the 3 carbons. I'm not going to join anything yet, I don't want confusion here, with the hydrogens that is left over. As you can see here, this one for instance was untouched, so it will have 3 hydrogen. This one have 1 hydrogen left, the chlorine was gone. This one have hydrogen, and the last hydrogen was gone there. So how can we solve that problem there? If each carbon needs 4 bonds, well, we'll make 1, 2 with hydrogens, 3 and 4 with that carbon, and the same happen for the second carbon. 1 with hydrogen, 2, 3 with the first carbon, and 4 with the last carbon. And this one is the organic compound that is formed here. But this is not all. This was just the organic compound, but we still have here the chlorine will go to react with the potassium there to form potassium chloride, and then still you have an OH here, an OH which is left with the hydrogen to form water, so it's a plus H2O. And this one is the balance reaction using structural formulas. Of these colors I have here, you don't have to add obvious. So in this question you will get 1 mark for each of those compounds. I think it's simple. Please go to watch the video I have of this type of reaction. And we're almost done with the question that was 7.2.2. We are about to finish. Reaction C take place in the presence of a strong acid. So let's go back to C, reaction C. Alright, reaction C is an alcohol, and you already know that this one is alkene, guys. Without getting even any further elimination, this is dehydration. That one is dehydration without any further analysis. Now the question said, explain the term secondary alcohol. It is quite important. I make just a video for that one, guys. This is not very short. This is an old video. The quality may not be the best, but it can still help. So secondary alcohol is a compound in which the hydroxyl group is attached to a carbon which is attached to 2 other carbon. So if we do this one here really fast, you have a carbon with have the OH, is that correct? Né? Now here, this carbon that have attached to the OH must be bonded to another 2 carbons. Like for example here, it cannot be bonded to 3. This one must be hydrogen, and therefore obvious, this is a secondary alcohol. The carbon that is attached to the OH is attached to 2 other carbon. That is what is a secondary alcohol. Write down the IUPAC name of the alcohol used. It was a secondary alcohol with 3 carbons. How do I know I have 3 carbons? Because here I have 3 carbon in this compound, and the number of carbon is not going to change. So secondary alcohol with 3 carbon is going to be propan 2-ol, and that is the answer and the end of the question paper. Guys, we are done. I hope it helped. It was a good question paper. It's a good practice. Thank you for watching. If you think it helped, please subscribe for the channel, thumb up, ask question, interact. I'll see you next time. Mr. G here.